So remember, inverses can only have one answer. So when we dealt with inverses, we had to limit our quadrants. We either used quadrants 1 and 2 or quadrants 1 and 4. Quadrant 1 was where everything was positive, and then we needed a quadrant where it's negative. So cosine is negative in 2, so we would do quadrants 1 and 2. Because this is a negative 1/2, that means we have to be in quadrant 2. Reference angle, when does cosine equal 1/2? 60 degrees. We were in, I didn't specify, so 60 degrees is fine. If you did radians, that would be pi over 3. So 60 degrees in quadrant 2, 180 minus 60 is 120. If you did radians, that would be 2 pi over 3. So either of those answers is fine. 32. We need sine 2 theta. So this formula, sine 2 theta is 2 sine theta cosine theta. We have sine theta in our problem. It gives us that that is negative 4/7, but I don't have cosine. So we need to find that. We know that sine is negative. So if we think about the all students take calculus, sine is negative in quadrants 3 and 4. And then it says cosine is greater than 0, so cosine is positive, so it has to be quadrant 4. Okay, so then sine was opposite over hypotenuse, so my opposite side is negative 4, hypotenuse is 7. Find your missing side. So we get radical 33. So then cosine adjacent over hypotenuse is radical 33 over 7. So if we multiply 2 times negative 4 times radical 33, so negative 8, radical 33 over 49. Okay. So these are the only stipulations we have, and we have to find all of our trig functions. What we can do is basically pick any point that we want. You know, if you think about when we first did these, we talked about angles, and we said, well, if you have an angle, no matter which point you pick on this line, you'll get the same ratio for sine, cosine, tangent, and so forth. So all we know is that x has to be less than 0. So x can be any negative number that you want. If I'm going to solve for y, I have to divide it by 2, so I'm going to pick negative 2 just to avoid fractions. So then if I plug in a negative 2 for my x, we get y to be negative 3. So now I have x and y. I mean, if you want to draw a picture, if x is negative and y is negative, we're in the third quadrant. So this side's negative 2, that's negative 3. Then you could find your hypotenuse. X squared plus y squared. So that missing side is the square root of 13. So sine, opposite over hypotenuse, so that would be negative 3 over the square root of 13, or negative 3 radical 13 over 13. Cosine, adjacent over hypotenuse, so negative 2 over radical 13, which turns into negative 2 radical 13 over 13. Tangent, opposite over adjacent, so negative 3 over negative 2 is positive 3x. So a lot of these problems ultimately come down to setting up a triangle. And then if you've got your triangle, you can get x, y, all of those things. You can then get any of your trig functions. Is that okay? All right. Okay, so this isn't worded greatly, but let's pretend we've got a pole and we have wires going down to the ground. And I want to know how far apart the ends of those wires are. So we have the pole, that height, and then we have these wires coming down, one on either end. When I say angle of elevation and depression, there were several of those on your study guide. Angle of elevation has to start at a horizontal line and go up. Angle of depression starts at a horizontal line and goes down. So if I drew this in, we need an angle of depression, so we have to have a horizontal. So we have to sketch in our horizontal here. So from there going down, one of these angles is 20 degrees. The other is 27 degrees. What do you know about the angle this pole would make with the ground? Was it? Yeah, we could assume that's a 90-degree angle. Okay. Our trig functions only work in a right triangle. Now we do have law of sines and cosines now, but whenever possible, if we have a right triangle, we want to use it. So let's start over here on the left. This green triangle is a right triangle. We need an angle in the triangle itself. So how would I get this angle up at the top? So that is 70 degrees. We're trying to find how far apart these 2 points are. So we need to find this side in our triangle. So from my 70, that's the opposite. 20 is adjacent. So we can say the tangent of 70 degrees equals x over 20. Multiply over your 20. Make sure you're in degree mode. That's one thing you will need to watch on your final. So 20 times the tangent of 70. 54.9495. So this angle would be 90 minus 27, so that's 63. We're trying to find this side. So we could say the tangent of 63 degrees equals y over 20. Multiply over the 20. And then we need the total distance. So you just add those together. So we get about 94.2. So if I wanted you to graph one period of y equals, let's say, 4 sine 3x minus pi over 2. Okay. So on these, I would kind of prompt you on certain things that I needed you to find. So I would say you have to tell me your amplitude, your period, the count by, the interval. So that way, you don't have to necessarily remember each of those. I would ask you those questions. How do you find your amplitude? Or number. Yeah. So amplitude is 4. Period is 2 pi divided by what? Yeah, the number with your x. So 2 pi over 3. Reduce that if possible, but we can't, so that one's good. Count by, how do we get that? So whatever we get for the period, divided by 4 for the 4 quadrants. And so that gives us, remember you can use your calculator, you just don't put in the pi. So you could say like 2/3 divided by 4. Interval. Sine normally starts at 0 and ends at 2 pi. You put the angle in the middle. So if I'm trying to solve for x here, we would have to add pi over 2 to everything. So 0 plus pi over 2 is pi over 2. Center equal to 3x. 2 pi plus pi over 2 would be 5 pi over 2. Divide everything by 3. So we have from pi over 6 to 5 pi over 6. Then we would have to graph it. So on your graph, things I'm going to be looking for. First of all, make sure it looks like a curve. If you draw me a sign that's a zigzag, that's going to be wrong. Second of all, try to space things out evenly on your x-axis. When we're doing the count by, it's the same distance between all of those. So this one started at pi over 6. We need 5 total points. And to get those, we just keep adding our count by, which is pi over 6. So pi over 6 plus pi over 6 is 2 pi over 6, which reduces to pi over 3. Plus pi over 6 is 3 pi over 6, or pi over 2. 4 pi over 6, which is 2 pi over 3. And 5 pi over 6. And we know we've done it correctly because that my interval was supposed to end at 5 pi over 6, and that's my final point. Amplitude is 4. We didn't move up or down on this graph, so my high point would be at positive 4. Low point would be negative 4. Where does sine begin? At 0. So pi over 6, that's where my interval began. We started at 0. Then sine goes up. Back down. And I know question 39 had you drawing all those graphs. Like, do you know the general shape of all the graphs? That sine starts at 0, cosine starts at 1. Secant and cosecant are their reciprocals. You know, your tangent and cotangent. So that's okay with everybody? Let's do, so something else that probably be worth more. A lot of the identities, I'm trying to think. So proofs and some of our like solving equations, I think we have a little more trouble with those. So let's try a couple. Let's see. If I told you to solve this on the interval 0 to 2 pi. so solving the equation. It's just like solving equations with variables only. You know, if I said x squared minus x equals 0, what would you do to solve that?
Yeah.
Yeah, you take out one of the x's. So if I have cosine squared minus cosine, we take out one of the cosines. So cosine squared divided by cosine, that leaves me with cosine x minus 1. So now we have two things multiplied that equal 0, so we set each of them equal to 0. Alright, so then at this point it's really a unit circle question. And remember, you can have a blank unit circle if it helps you. It will not be graded, so it's not something you have to do, but I will certainly have copies if you need to fill one out. When I look at this, cosine is the x on the unit circle. When does x equal 0? And we said for radians, so that would be pi over 2 and 3 pi over 2. So that's when my cosine equals 0. Then, when is cosine 1? So on my unit circle, when does x equal 1?
0.
And that would be my answer.
Do we have those ones when like you have to? I can't remember. It's like something like. I can't think about it. I might have it in my notes.
Are you going to say like when we had double solutions and
Yeah,
those
like,
types of things?
Yeah, probably. I gotta look at it first, actually, though.
Okay.
Okay, this is a whole different thing, but I was like talking about like the solve the triangles and then like.
Finding
Yeah.
Oh, the two triangles?
Yeah. Do we
Oh,
have
the law of sines when we had two different triangles that showed up?
Yeah.
Is that what you're saying?
I don't think we did that on study guide, did we?
I don't think there was one.
I
Study
could.
guide.
So
I was
then-
terrible at that.
Okay, can we do one like 13?
Sure.
Because I always struggle when we have to like do the convert the stuff.
Oh, okay.
Oh yeah, this one breaks down terrible.
Alright, so let's see. The key to these problems is anything with involving an angle or an angular velocity. They have to be in radians. So if I said so radius is r, so the r is 8. 12 revolutions per minute, what is that? Okay, we are looking for linear velocity, which is, so we're going to do both r and omega. Okay, but here's the problem. I can't plug them in that formula yet. Why? Yeah. to use the formula, if it's theta or omega, it has to be in radians. So I can't use this revolutions per minute. So there's different ways of converting this. What I usually wrote out, we have 12 revolutions per minute. I don't want revolutions, so if they're on top, to cancel it, it has to go on the bottom. I want radians, so I'm going to put radians on top. 1 revolution is all the way around the circle, so that would be 2 pi radians. So the revolutions cancel. 12 times 2 pi is 24 pi radians per minute. So then V equals the R, which is 8, omega, which is 24 pi. So we get 192 pi, and that would be inches per minute. The terminal side of an angle lies on, let's say, 3x plus 4y equals 0. Let's say x is less than 0. I don't want sine, cosine, tangent. So you can take any x value you want as long as it meets the requirement, which is that it is less than 0. So we need an x that is negative. So what could we use?
-1.
Okay. So if x is -1, we get y to be 3/4. We can keep that. If you don't like having fractions, if that bothers you, there's an easy solution. If you don't want 3/4 to be a fraction, what would you have to multiply by? 4. So if I multiply y by 4, you just take your x times 4. So we could use -4 and +3 if we want to avoid fractions.
So you just multiply by
The denominator, yep. Alright, so then we can set up a triangle. My x was -4, y is +3. So there's my angle. So this side's -4, this side is 3, so Pythagorean theorem. Oh, I didn't mean to give you one that worked out. I wasn't even thinking. So C is 5. And you could have radicals there. Just if it's a radical, like if it were 50, radical 50, you would reduce that as much as possible. Okay, so then we just set up SOHCAHTOA. Sine, opposite over hypotenuse, so 3/5. Cosine, adjacent over hypotenuse, so -4/5. Tangent, opposite over adjacent, so 3 over -4. What if I said So, it said use co-functions. So if you have secant, what is the co-function for secant?
Cosine.
That's a reciprocal.
Shoot,
Cosecant. The co-function just has the co in front of it. So sine and cosine, tangent, cotangent, secant, cosecant. And when are co-functions equal? Yeah, when their angles add up to 90, when they're complementary. If you think about like on our hand trick, sine of 30 equals the cosine of 60, right? Sine of 45 is the same as the cosine of 45 because sine and cosine are cofunctions. They're equal when those angles add up to 90. So we just have to figure out this angle. So what we know then is 150 plus x has to equal 90. So if you subtract your 150, we get negative 60. So it is cosecant of negative 60 degrees. Trying to think of the ones that a lot of people have asked me about. What if I said find sine of arc cosine 2/3. What did we have to do on these? There was one on the last
Do
time.
with the triangle.
Yeah. The answer to an inverse, and arc cosine is just another way of saying cosine inverse, the answer to that is always an angle. And so what we have to do is find sine of that angle. So if we set up a triangle, cosine is adjacent over hypotenuse. We need to get that. So a squared, b squared equals c squared. And our c is 3. So this side would be the square root of 5. So if I said the sine is opposite over hypotenuse, so that would be radical 5 over 3. Find theta so that cosecant is equal to negative 0.214. So we need quadrants and reference angles. And which quadrants is cosecant negative? Cosecant is the reciprocal of what? Sine. So when is sine negative?
2, 3, 4.
Okay, so we will have two answers, one in each of those. Reference angle. Do we know when cosecant is negative 0.214? No, so we're going to have to use our calculator. Let's do degrees. If you want to type this in though, we have to be a little bit careful. Cosecant is the reciprocal of sine, so that means sine is 1 over that. To get your reference angle, you have to do sine inverse, so second sine, of 1 over 0.214. Don't put in the negative. I didn't make a problem that actually worked, did I? Can I change something? Let's make this 1.214. I wasn't even thinking. Can I do that?
Mm-hmm.
So we get a reference angle of 55, let's just go to the nearest 10, 55.5 degrees. So to find our actual angle, to put that in quadrant 3, you do 180 plus that. So 180 plus 55.5. That gives you 235.5. And then you have to do, for quadrant 4, 360 minus 55.5. We get 304.5 degrees. Is that one okay?
So quadrant 3, you always add 180.
Mm-hmm. I said find the exact value of the tangent of 690 degrees. Exact value, when I say that, that means not what the calculator tells us in terms of, because I want radicals. But 690 is not something that rings a bell with our unit circle. What do we need to do?
Subtract the 60.
Mm-hmm. So that would give us the tangent of 330. What quadrant is that in?
4.
Reference angle?
30.
So in quadrant 4 is tangent positive or negative? And the tangent of 30?
1. Radical. Shoot.
Radical 303.
Because it's 1 over the radical 3 if you're looking at your hand trick. Along those lines, we had one that gave you a lot of trouble, or gave people a lot of trouble on the study guide. It said give the exact value, and then it had something like 3 times the sine of negative 5 pi over 4. So if that angle is negative, what do I need to do?
Add 2 pi.
Add 2 pi. So negative 5 over 4 plus 2. So that's like 8 pi over 4, so we get 3 pi over 4. What quadrant is that in?
2.
Reference angle is, so the 3 just trails along. In quadrant 2 is sine positive or negative. Okay? And sine of pi over 4? So we just get 3 radical 2 over 2.
Terrible at the